and this is our Z, okay, fracture will occur on this surface over here. And this surface is your what? Is your YZ plane. And your YZ plane is what? Of plane. If we were to induce a stress on stress Y direction, again, fracture will occur on this surface. And this surface is known as your XZ plane. And this surface is also our out of what? Plane. For this reason, okay, we are very stress plane. You can observe the fracture will occur either on the YZ plane or XZ plane. Okay? So later on, when we analyze this, you know, hey, something is not the same down here. Okay? Something's changed. Okay. Now, with this, you have to get this fundamentally clear. Why you have to get this fundamentally clear is because when I speak about an element, now you have a vision. What is that element in real life? Yes or no? You have an impression. Okay, you said. Now, where you position this element is where fracture will likely occur. So now, if you have a cantilever beam, where will you place that element? Will you place that element at the free end or at the end that's not deflecting? Where will you place it? So if where to place it is where it will likely fracture. So if I put my hand down here, where will this thing break? My right hand or where? The one with my pen or the one without my pen? Without my pen. Why will it break over there? Because of what? Moment is what? Maximum. Or when Eugene jump from the 5th floor, when will he die? When you don't allow him to what? Are we clear? Okay, so you will place your element exactly where fracture will what? Occur. Some people just don't know where and they put everywhere. Point. Be clear. We want to know where it will break. That's where you place your element. So from here, I'm going to talk to you about an element. So with an element, I'm now going to focus on just 2D. Okay. And then this is our transformation X and Y. Okay. So what we have over here is stress X and stress Y. Okay. So stress X denote the normal stress acting in the X direction. Stress Y denote the normal stress acting in the Y direction. Okay. So you know that this is 90 degrees. That's why it's normal. This is also 90 degrees. And from here, because the stresses are pulling up away from the surface, stress X and stress Y, they are both what? Positive. Positive denotes what? Tensile. Okay. If we were to look at another element, and then we have a stress state where this is our stress X and this is our stress Y. The difference with this one and the other one is both stress X and stress Y are negative, pointing towards is negative. This is denotes that it's under what? Compression. Okay, that denotes that is compression. And then another stress state, I'm going to write over here. Stress X is under what? Negative is under what? Compression. Stress Y is equal to what? Anyone? 0. Means it's not under stress. Because we are engineers, it's equal to 0. If you ask a lawyer, you say how much you willing to pay. Yeah. So stress X or stress Y over there is equal to 0. Now, how is this related to Mohr circle? So now you know an element. Right? You know what's an element now. You know how the normal stress responds. Now, how is this related to Mohr circle? Okay. So next, we are going to construct Mohr circle. Okay. Before we go into the Mohr circle, I want you to first of all understand the rules of a circle. Okay. So my advice is immediately go and buy a mathematical set. The first thing I'm going to draw now is I'm going to draw a circle. Okay. So this is my circle, and this is the center of my circle. Okay, that is the center of my circle. Okay, the center of the circle, usually we label it as O. Okay, or just put O. Then from here, I'm going to draw a line, a straight line, through the center of the circle, and you draw any orientation that you want. Okay, I decide to draw in this orientation. If you want to do any other orientation, feel free to do so. Okay. Once you get over here, we are going to label one end A, and the other end is B. Okay. And from here, I'm going to pick a point, and this point I'm going to pick is known as point C. Okay. After picking point C, I'm going to draw a line from point A to join point C. And then from point C, I'm going to join to my point B. And if you have done that, it's always a fact that this is equal to 90 degrees. Always. Okay, if you were to construct that properly, you always will see that it's equal to 90 degrees. From here, I'm going to now draw a line from point C to point O. Okay, from point C to point O. And I'm like to label this angle CAO as alpha. Okay, or CAB. And we know COB over here, this is equal to 2 alpha. And why is that? is because this distance over here is your radius. This distance is also your radius. When that's the case, the angle over here is also known as your alpha. The angle over here will be known as 180 minus by 2 alpha. Okay. So this is what we know as the rules of a triangle. Okay. There might be some other name. I just made that shit up. Okay, but I call it rules of a circle. Okay. Right. So from here, the next thing that we're going to do is we are going to relate the element to Mohr circle. Okay. So we will sketch out an element over here. This is my stress X. Over here, this is my stress Y. And I will declare that stress X is greater than stress Y. Okay. A very good practice to do. Once you know this surface, you label this as point X. You label this as point Y. Okay. And then now we are going to sketch Mohr circle. Okay, now we are going to sketch Mohr circle. So on Mohr circle, your x-axis is known as your normal stress. Repeat again. On Mohr circle, your x-axis is known as your normal stress. And then on Mohr circle, your vertical axis is known as your shearing stress. Okay. And the center is 0. Towards the right, it means that the stress are what? Positive, which denote what? It's in tensor. Towards the left, it means that the normal stress is negative, that denotes that it's under what? Compression. Now, on the shear, I want you to have a very good habit, okay, because this is important. I want you to have a good habit. In shear, the element will rotate clockwise at the top, at bottom will rotate anti-clockwise. I want you all to have that habit of doing that first, and I'll explain to you why later on. Okay. So now, building going to collapse or what? So now, we just define that over here, this is known as your stress X line. And then we have another point over here. This is defined as our stress Y line. I think someone trying to turn on the air conditioning, okay? As you can see over here, we realize that there is no what? There is no shearing stresses. So when that's the case, we know at this point, this is known as our point X. At this point, this is known as our point what? Y. Okay. So you know the values of the two extreme points. You can now construct Mohr circle. Okay. Now I want you to observe this now. Give me 2 more minutes. Okay. At the center over here, I'm going to draw a point O. Okay. Now, from point X to point Y on Mohr circle is how many degrees relative to the center of the circle? What is this angle equal to? Any idea? 180 degrees. Or I can call this 2 theta. Okay, so on Mohr circle, we have 2 theta. Okay, now why is this important? Now I want you to look back at the element. In the element from point X to point Y, what is the angle over here? Which is equal to what? Theta. So what's the point of telling you this? In Mohr circle, if the angle is 45 degrees, if you bring back to the real world, it's equal to 100 degrees. Yeah. Okay. I'll see you guys more exciting times tomorrow.